welcome back to part 2 of graphing quadratic functions. In this lesson, we are going to graph the quadratic functions by using the key features and tables that we have learned last time. First, let us revise what is the standard form of the quadratic function. The standard form of the quadratic function is y equals ax squared plus bx plus c, where a, b, and c are constants. A, B, and C are constants, okay? And A is always the coefficient of the x squared, and B is always the coefficient of x, and C is always the constant. So these three letters, we are going to give it to these coefficients of A, x squared, and x, and the constant C. Now let us move to how we graph the quadratic functions. The first step is to find the axis of symmetry. To find the axis of symmetry, we will use the formula negative b over 2a. So the axis of symmetry equals negative b over 2a. Okay, again, what is b? b is the coefficient of x, and a is the coefficient of x squared. So negative the coefficient of x over 2 times the coefficient of x squared will give me the axis of symmetry, and it will be at x equals. So axis of symmetry is always at the point x equals negative b over 2a. So this formula is very important to remember. Also, we can call it another name. We call it the abscissa. We call it the abscissa of the vertex. And we know now why is it the abscissa of the vertex. Abscissa means the x coordinate. So here is a vocabulary word. Abscissa means the x coordinate of any point. So an abscissa of any point is the x coordinate, while the abscissa of the vertex is the x coordinate of the vertex, and it is at the same time the axis of symmetry, where x equals negative b over 2a. So this is the abscissa. Now to find the y of the vertex, we have a name for it. It's called ordinate. It's called the ordinate. So the ordinate of any point is the y coordinate of this point, and it is given by, let me write here just y coordinate. Okay, and to find any y of input x, to find the y of the specific x that we have, we are going to substitute the value of negative b over 2a, the value that we will get here, we'll substitute it in the equation here. So the y coordinate is a times x squared, which is negative b over 2a, what we'll get here, and make it power 2, plus b times the x, which is negative b over 2a, which we'll find it here, it will be with a value, plus c. So here are the steps to graph the quadratic functions. The first step is find the equation of the axis of symmetry, and we said we will use a negative b over 2a. So this is x of the axis of symmetry, and it is at the same time the abscissa, or the x coordinate of the vertex. So the vertex, which is the second point, or the second step, step number 2, find the vertex and determine whether it is a maximum or minimum. First, to find the vertex, we said it in the last slide, the vertex, which is the x and y coordinates. So the x coordinate is negative b over 2a, and the y coordinate is f of negative b over 2a. By plugging in the value that we will get here for the abscissa, we plug it in the function that we have to get its y value. Also, we must determine whether it is a maximum point or minimum point. Remember, when we graphed the function last time, I said if it opens upwards, then the vertex is minimum. And when the parabola open downwards, the vertex is at the maximum. also we said the last video that in the minimum, okay, when the vertex is minimum and the parabola opens upwards, this means that a is positive, is greater than 0. And if the parabola is opening downwards, this means that a is less than 0. So a determines if the vertex is maximum or minimum. So of course, if a is greater than 0, then the vertex will be minimum. And if a is less than 0, then the vertex is maximum. Step number 3 is to find the y-intercept. To find the y-intercept. The y-intercept is very easy to find. Just let y-intercept equals the constant c. We know that y equals ax squared plus bx plus c. This is the standard form. So when the y-intercept means at x equals 0. So at x equals 0, any graph, the y-intercept always the x equals 0 to find the y-intercept. So x equals 0 will give you the y-intercept. If you substitute here x by 0 and x by 0, these will be removed and what remains is only c. So that's why to find the y-intercept, it is equal to the constant c. Step number 4 and step number 5, we use symmetry to find additional points, and I will show you this through the example, and then we connect the points with a smooth curve. Now I'll show you the example, and we will apply these 5 steps to graph the parabola. So in this example, we have f of x equals x squared plus 2x minus 6. Now before doing anything, I want you to write what is a, b, and c. So we have a is the coefficient of x squared, and here the coefficient is 1 because it's hidden, so we do not always write 1, so a is 1. While b is the coefficient of x and it is positive 2, and c is the constant and it's equal to negative 6. Now let us do the same steps that was in the first slide. So the first step is to find the axis of symmetry. And the axis of symmetry equals negative b over 2a. So we know that axis of symmetry equals negative b over 2a. And this is equal to, in our example here, negative b, which is negative 2 over 2a, that is 2 times 1. So negative 2 over 2 is negative 1. Okay, when I do the axis of symmetry, I go to the graph, and at the point negative 1, I will draw the dashed line, which is the axis of symmetry. This is at negative 1. So can you see what I'm doing here? This is how I start the graph. Step number 2 is to find the vertex. And we know that the vertex is a point at negative 1, which is the axis of symmetry. So the axis of symmetry is the same like the axis of the vertex, because the vertex point lies on the axis of symmetry. We know this. And it's negative 1 and y of negative 1. How do I find the y of negative 1? I'm going to substitute in the equation above f of negative 1. So I will find f of negative 1 because x is negative 1. This is the x of the vertex, and I need to find this y. Y, which is f of negative 1, this is the y, okay? F of negative 1, I'm going to replace each x in the equation here by negative 1. So I'll put negative 1 squared, this is x squared, plus 2x, this means 2 times negative 1, minus 6. You can use the calculator or you can just do it mentally, and this will be negative 7. So this means that the y is negative 7, then the vertex is at, so the vertex, now I have the complete point of the vertex at negative 1 and negative 7. This is the vertex. So move on the graph and put the point which is negative 1 and negative 7 on the axis of symmetry. So here is negative 1 and 1, 2, 3, 4, 5, 6, and 7. So at this point here, this is the vertex. Okay, I'll point at this vertex here. This is the vertex point at negative 1 and negative 7. Okay, what was the third step, if you remember? The third step was, I will write it here, third step, step number 3, is the y-intercept. Y-intercept. And we said that the y-intercept equals the constant c. And what is the constant in our equation here? It is -6. So this means that at y is -6, I will put my point at the y-axis. So here's the point, and I will put here, this is the point, the y-intercept equals -6. Okay, remember that the axis of symmetry cuts the parabola into two identical parts. So every point on the right of the line of symmetry has its image on the left of the line of symmetry. So here we have a point on the right side, which is the y-intercept. Okay, we will measure how many units between this point y-intercept and the line of symmetry. So it is 1 unit. So I'm going to move or count 1 unit to the left and put the image of the y-intercept on the left. So now I have 3 points: the vertex point, the y-intercept, and its image. So this is the image. I will write it here. This is the image of the y-intercept. Now, additional points. Step number 4, and I said we are going to explain it while we are solving. We need 2 additional points so that our parabola will look nice. So additional points to find, I'm going to take any point on the x-axis, except for x is 0, because x is 0 is already at y-intercept, and except for the x -1, because this is the vertex. So we can take additional point at x equals 1, for example, and find the y of this x. So when x is 1, what will be the y? Let us see here. As an example, you can take at x equals 1. So we're going to find the f of 1, which is the y. F of 1, so right in this equation, replace x by 1. It will be 1 squared plus 2 times 1 minus 6. And this is equal to -3. So at 1, we have 1 and -3, and this is the point here. This is at 1 and -3. This is additional point, okay, at 1 and -3. And remember, if any point I have it on the right of the line of symmetry, I have the same image on the left. So count between this point and the line of symmetry how many units. This is 1 and this is 2. So I'm going to count on the left also 2 units like this, 1, 2, and I will put the image of 1 and 3. Now I have how many points? I have 5 points. The vertex, the y-intercept, the image of the y-intercept, additional point, and the image of the additional point. Now I can graph the parabola by connecting the lines smoothly like this. Okay, smoothly like this. And just extend it a little bit like this. So it will look like this. Now it's your turn. Do this exit ticket. I want you to solve it and try to get the best graph ever and show me. See you. Bye bye.